the AC OK exists in the pin 127, so we have 3 volt in the multimeter, so AC OK is good. 19.1 volt. This is the DC in. Let's check. We have 19 volt in the multimeter. So we have here PQ52. These 3 pins are source and this is the gate. Let's check. Hi everyone, so welcome again to this video where I'm going to teach you the charge circuit from A to Z. So please, because this is the first video where you see my face, I want more likes for this video. This video will be one of the top videos in my channel. So please guys, why this course is a very important course and is one of the top course in my YouTube channel, because upon completion of this course, you will be able to fix battery not charging issues, battery not detected, battery works on adapter but not on battery, battery not recognized, laptop only powers on battery but not on adapter, laptop turns off when unplugged, battery drains too quickly, adapter connected not charging, battery percentage stuck, laptop charging slowly, laptop charging but not increasing percentage, plugged in not charging issue, inconsistent charging behavior, laptop charging light blinking not showing, laptop doesn't recognize the adapter, and finally power adapter overheating. So please, if you suffer from any of these issues, stay tuned. This video will help you a lot. This is the top simplified schematic that will help you understand the charge circuit 100%. So this schematic is the same as this here. We're gonna see the theoretical part here in the table where I'm going to teach you how to follow voltages, and of course we're gonna see all here in this motherboard using the multimeter. So please stay tuned. Let's get started. So first, let's see an overview about this schematic. Here we have the DC jack. As you can see, we have the PJP1. So this is the DC jack in the motherboard, PJP1. We have the PL24 inductor, the PL24 inductor, this one, next to the DC jack. This is the input inductor. And over here we have 2 MOSFETs or switches. This is the first MOSFET, PQ51, and the second MOSFET, PQ52. So this MOSFET is PQ51, and in the other side we will find PQ52. This is PQ52 MOSFET, always next to the DC jack. So basically this MOSFET is used for protection, and this one we called it a switch because it let 19 volt to pass from this side to this side. We have the current sense resistor, PR351. Here we have the current sense resistor, PR351, next to the battery connector. The purpose of the current sense resistor is to calculate the current consumed by the whole motherboard. Here we have the charge IC, PU17. Its reference is ICL6251. This is the charge IC, we have PU17. And for the reference, as you can see, we have ICL6251. We have the SIO. This is the circuit that is responsible for the management of the whole power in the motherboard. This is the SIO or the super IO. So here we have 2 voltage regulators that will generate the 12 volt to charge the battery. Then here we have the MOSFET or the switch for the battery, and also its inductor, PL45. But this channel will only work when the adapter is removed. So now let's see how voltage travel in the circuit step by step from one point to other points. First of all, we have the Vin. So Vin equal to 19 volts. the V-in will pass through this inductor and it will be present here in the drain of this MOSFET, PQ51. So let's check PQ51. So this is the MOSFET. As you can see here, we have PQ51. Okay, this reference PQ56 is for this MOSFET. Okay, here 3-pin MOSFET, but PQ51, this is it. Here we have this dot, means this is the source, and over here we have the gate, and this is the drain. We have to find 19 volt is in the drain. So let's check. We have 19 volt in the multimeter. So we find 19 volt. 19 volt is present. Then 19 volt will go in this direction, as you can see, and in this direction to power this IC. We have here the DC in. So the DC in signal is about 19 volts. It is the working voltage for this IC. So without the DC in, the IC will not work, means we will not get 12 volt, we will not get anything in the circuit. So let's check the DC in the pin 24. We have to find 19 volts. So this is the charge IC. This dot here means this is the pin number 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here we have 12 and over here we have 12. So the pin 24 is this one, because the reading is like this, counterclockwise. Okay, 1 we have here 1. This is the pin number 12. Here we have 13, 14, 15 until 24. So this pin is the pin 24. So let's check this pin. We have to find 19 volt in the multimeter. This is the DC in. Let's check. We have 19 volt in the multimeter. So the DC in is correct. Good. So once we find 19 volt, let's see the next step. So here we have the first step. So this is the second step. The third step is the 19 voltage will go in this direction, as you can see. Of course, it will pass through this resistor, PR359, and it will be applied to pin number 3 in the charge IC. So because we have these two resistors about 100 kilo ohm, we will not get 19 volt here like the DC in. We will get a voltage usually between 1.2 volt and 3.3 volt. So let's check in the IC. So this is always the charge IC. Let's locate the pin number 3. So this is the pin number 3 here. So 1, 2, 3. This pin number 3 is connected to this resistor. Do you see this part here? This small part means we have connection. So let's check here in this resistor. We have 1.3 volts. We find 1.3 volt. So this step is good and the third step also is good. Next, once the charge IC get these two signals, this is basically two input signals. We called it also enable signals. Once it get these signals here, this one and this one, it will then generate the EC drive. So this is the step number 4. The EC drive will activate these two gates. Then the 19 voltage will pass in this direction. But let's first check EC drive. So for EC drive, it's about 8 volt. So let's check the gate of this MOSFET PQ51 and this MOSFET PQ52. So let's check the AC drive in the motherboard. We have to find 8 volt in the gate of PQ51 and PQ52. So let's check first the gate of this MOSFET. So here we have this dot, means this is the pin number 1, 2, 3 and 4. So the gate always is in the pin number 4. So let's check pin number 4. We have to find 8 volts. As you can see in the multimeter, we have 8 volt. So the AC drive here is good. Let's now check the other MOSFET, PQ52. So the second MOSFET is in the other side of the motherboard. So we have here PQ52. So this is the gate, because here we have this dot, means these 3 pins are source, and this is the gate. Let's check. Also we have 8 volt. So the AC drive is good in both MOSFETs. So I will prove to you why generating the AC detect or the AC in, we called it sometimes AC set or also enable. We can call this signal enable. So this signal is very important. Without this signal, the AC drive will not be generated. Let's see the proof. Please pay attention. This functional diagram is apart from the charge IC. Do you see here the gate signals, these 2 signals? In order to be generated, this IC should receive this enable signal. So this enable signal will activate this IC. And then this IC will generate an output to activate this IC, and then this IC will generate the control signals, as you can see, for the gates. So in our case, the enable here is the AC in, about 1.3 volts. So once we find 8 volt in these 2 gates, means these 2 MOSFETs are activated. So a 19 volt will pass here. We will get here 19 volt. So this step also is good. 19 volt also will pass through this current sense resistors, and then we will get B plus 19 volts. Let's check 19 volt in both sides of this current sense resistor, PR351. So we have the current sense resistor PR351. Let's check 19 volt in both sides. So here we have to find 19 volt. This is good. Let's check the other side. We have 19 volt. So once we find 19 volt in both sides of this resistors, why in both sides? Because resistance is about 0.02 ohm. So the B plus is good. So this step is good. We get the B plus. From here, the voltage will be distributed to the whole circuit of the motherboard, including the CPU circuit, the RAM circuit, etc. So let's check if this B plus is distributed to the whole motherboard or to the whole circuit in the motherboard. So now we gotta check if the 19 volt is distributed to all circuit in the motherboard. So let's begin with this circuit. Here we have this inductor. We have to always locate this inductor. We have to find 19 volt. We have 19 volt. This is 3 volt, 5 volt circuit. Here we have the NOT bridge circuit. Let's see if we have 19 volt or not. We have 19 volt. Also here we have the CPU circuit. Let's check this inductor. We have 19 volt. Let's go and check the graphic card inductor. We have PL, means this is inductor. We have to find 19 volt. This is good. Let's go ahead and check the RAM circuit. We have PL inductor here. Let's check. We have 19 volt. Why I check 19 volt in this kind of inductors? Because those inductors are always in every input for every circuit. So the 19 volt is distributed to all circuits in the motherboard. Good. We find that the B plus is distributed to all circuit in the motherboard. Means this step also, the step number 6 is also good. The distribution of the main voltage is done 100%. Now the 19 volt will pass through these inductors directly to source of this MOSFET, PQ53. But it will stop here in the source. It will not pass to other side, because if it's passed to this side, it will damage the battery, because the maximum voltage of the battery is 12 volt. Why the voltage will not pass to this side? Because this MOSFET contains inside it a protection diode that will not let the voltage to pass in this side. So let's check this MOSFET. We have to find 90 volt in its source, but the drain we should find 0 volt. So let's check in the motherboard. So this is PQ53, as you can see. Here we have this dot, means this is source. So we have to find 19 volt in the source, as you can see in the multimeter, but in the drain we have to find 0 volt, as you can see. So here it's a good MOSFET. The battery is protected. So the next step here is this. The 19 volt will travel in this direction. So we will get 19 volt here in the drain of PQ62. So this is the step number 7. Let's check the drain of this MOSFET, PQ62. So we have here PQ62, as you can see. So this is source. You have to always locate this point, because the point always refer to the pin number 1. So 3 pins here for source. This is the gate, and over here we have the drain. So we have to find 19 volt in the drain. Let's check. We have 19 volt in the multimeter. So the 19 volt is present. Means the last step about the main voltage is good. Now let's move on to the next chapter. So once the charge IC detects or receives the DC in, the AC in, and also the B plus is here and is distributed to all circuit in the motherboard, the charge circuit will begin send the AC OK to this IC, to the super IO, about 3.3 volts. So let's verify the AC OK in the motherboard. So this is the SIO, as you can see, near to the charge IC. So the AC OK exists in the pin 127, as you can see in the schematic. So let's check the pin 127. So as you can see, this mark here means this is the pin number 1. Over here we have 32, the pin number 32, 33. Here we have 64, here 65, here we have 96, 97, and over here we have 128. So the pin 127 should be this pin. So we have 3 volt in the multimeter, so AC OK is good. So we find the AC OK, means the number 8 is good. The AC OK is good. So the AC OK that the charge circuit sent to the SIO is the same as power good. The charge IC here inform the SIO because this is the bus. Here we have bus. So this is the big bus in the charge circuit. Always the charge IC refer to its bus. That's why this IC is the IC that manage the whole power in the motherboard. So the charge IC will inform this bus that the AC in is detected, the DC in is detected, and also the main voltage is distributed correctly. So then the SIO will send another signal here. Basically this is SMD data, okay, and also SMD clock, the same as those, but those signals will be sent to the battery. Okay, we're gonna discuss the signals after. So after receiving the AC OK, the SIO will send the SMB data and SMB clock signal to this IC to generate the upper gate. Here we have 10. Okay, here also we have 10. Okay, to generate the upper gate to these two MOSFETs, we have PQ62 and PQ64. These two MOSFETs will then generate the 12 volt to the battery. Here, guys, I have a question. Why we always speak about 12 volt, not 19 volt or 18 volt? Why? So let me explain to you and teach to you how the battery works in order to understand why 12 volt and not 19 volt. Let's get started. So do you see here? Basically, the battery for the laptop composed of 6 cells. Okay, we have these 3 cells are connected in series. Okay, and for each cell we have 3.7 volts, 2 amps, 3.7 2 amps, 3.7 2 amps. So when we connect the cells in series, means the voltage will be added, will be increased, but the current will remain the same. So means we have 3.7 here, 3.7, 3.7. So 3.7 plus 3.7 plus 3.7 equal 19.1 volts. Means 12 volts. Okay, we have another arrow here where we have 3 other cells. Okay, so these 3 other cells also is in series, means we have here 12 volts, 2 amps. Okay, and here we have 12 volts, 2 amps, because those in series and those in series. Now the 2 arrows is in parallel, means what? When we have 2 blocks of cells in parallel, means what? Means the current will be added, means 2 amps plus 2 amps will be 4 amps. Okay, we have here 4 amps, but in parallel the voltage will not be added, will remain the same voltage, means we have here 12 volt, 12 volt, it will be 12 volts. So within the battery we have 12 volt, 4 amps. That's why these 2 voltage regulators generate 12 volt, not 19 volt, not 18 volt, because the maximum voltage that the battery can support is 12 volt based on its configuration. 6 cells with the characteristics of 3.7 volt, 2 amps. So the next step, guys, this is a very important step, please pay attention. The next step is to generate these signals. This is a very important signals that I want you to understand. Very important signals. Here we have the bath temperature or battery temperature. We have the SMB data and SMB clock. So right now I will explain to you what is SMB data, SMB clock and SMB temperature, and why we use this kind of signals and what is the purpose of these signals. So before explaining these 3 signals, let's first take the measurement in the motherboard. So for SMB temperature, we gotta find it in the pin number 4 of the battery connector. SMB data in pin number 5, SMB clock in pin number 6. We gotta find 3.3 volt. So let's check the motherboard and then come back and explain these 3 signals. So in the motherboard, this is the battery connector here, and we have this mark here. Do you see this triangle? Means this is the pin number 1, pin number 2, 3, 4. So pin number 4 is for SMB temperature. We have to find 3.3 volts. Let's check. We have 3.3 volt. So pin number 5, this is SMB data. We have to find 3.3 volt, as you can see in the multimeter, and the pin number 6 is for the clock, 3.3 volt. So we have the 3.3 volt in these 3 pins. So good. Once we check the 3 signals, we find 3.3 volt. Let's now explain it. What is these signals? So for battery temperature, based on this signal, the SIO will make sure that the heat of the battery is within normal, is good. It's not overheated, because if the battery is overheated, the SIO will shut down the charge IC working. For the SMD data, of course, the SIO will know about the state of the battery. For example, what is the level of the battery? Is it 50%, 40%, 90%, etc. Once the battery, for example, reach 100%, the SIO will know that the battery reach 100%, so the SIO will send another signal called SMD data for the charge IC to stop the control signal. So it will stop generating the control signal to gate of this MOSFET, then the 12 volt will stop be generating. And for SMD clock, we called it clock or timing, okay? Timing. This signal basically is the clock signal, because all components in the motherboard need the clock, for synchronization in order to work properly. So we find that those signals are good. So here we have the step number 11 is good. So guys, right now let's summarize what we have seen before. So we have seen that this is the DC jack. Okay, once the adapter is plugged, the 19 volt will pass here to drain of this MOSFET, but it will not pass to this side. So until these two MOSFETs or switches receive the AC drive from the charge circuit. But before generating the AC drive, the charge IC should receive some inputs, including the DC in 19 volt and also the AC in about 1.2 volt to 3.3 volt. For our example, we find 1.3 volt. So once the charge IC receives the signal, it then generates the AC drive to the gate of these two MOSFETs. Then the 19 volt will pass to this side. So we can get here the B+. The B+ is the main voltage for the whole motherboard. It will be distributed to all circuits in the motherboard. And of course, we will get here 19 volt in the drain of this MOSFET. These two MOSFETs, of course, will generate the voltage to charge the battery. So once these two signals and the AC drive is generated and the main voltage here is good, the charge IC will then generate the AC, okay, to the bus or the super IO. So the super IO will know that the voltage here is managed 100% good. So the SIO will generate a signal telling the charge IC, go ahead and generate the low gate and the upper gate for these two MOSFETs in order to generate 12 volt for the battery, in order to charge the battery. Basically, and by the way, we have here another current sense resistor exactly like this one, but this one here, its purpose is to measure and to calculate the current consumed by the battery. I have here another tip. Why? As you can see here, we have the path here. The 12 volt will be generated to charge the battery, and we have also here another feedback to this IC. This is basically, we called it the phase. The phase here will let the IC to know whether the 12 volt is generated or not. If, for example, the 12 volt is not exact, for example, let's assume we get here 14 volt, so this IC will readjust this signal for lower gate and upper gate in order to get the 12 volt, the exact voltage. So after generating this voltage, we have also these three signals that will be generated about the same time. We have the battery temperature in order to know all about the temperature for the battery. If the battery is overheated, this IC will shut off this charge circuit. We have the SMD data to know about the state and the level of the battery, and SMD clock for timing or synchronization. So guys, now we reach the most important chapter in this video, is to teach you every issue and the probable component that can cause this issue. So let's begin with battery not charging. So battery not charging means what exactly? Means the 12 volt here is not generated to this battery. Means what exactly? Means it could be, the problem could be in this MOSFET, one of these two MOSFETs. It could be the short circuit, and of course when we talk about short circuit, this is the probable component that could be shorted because it is connected to the ground, and also this capacitor. If this capacitor is shorted, the 12 volt will go to the ground, directly to the ground, not to the battery. Or it could be the IC. So if the IC is not generate the lower gate and the upper gate, so we cannot get 12 volt, so the battery will not be charged. Of course, we cannot see that the IC is bad. We should first check its inputs. And the most important input here is to check the EC OK. Is EC OK present or not? Because before generating the signal to activate these two MOSFETs, this IC should first send the AC OK to the SIO. The SIO, of course, could receive the AC OK, but if the SIO is failed, it cannot send this signal. So for this problem about battery not charging, it could be this two MOSFET, it could be this capacitor, it could be the battery itself if we have a bad battery, it could be the connector, the battery connector, could be the charge circuit, and it could be the SIO. So let's move on to the next issue, battery not detected. So if the battery is not detected, automatically it could be the problem the battery itself or the motherboard within the battery, because the battery contains a motherboard inside it. It could be this connector, the battery connector, and it could be also the SIO or the super IO. Why? Because battery not connected, this is the signal that tells us if the battery is connected or not, SMD data. So if we have a problem with this signal, means the problem could be here in the SIO. So now let's move on to the next issue. Laptop works on adapter but not on the battery. So when the laptop works on adapter but not in the battery, means we have problem in this side. So it could be this MOSFET, because this is the switch for the battery. Of course, it could be the battery itself, it could be the battery connected, but this is the probable component that could be failure. You should always check this component and also check this inductor. Because if this component is failed, the 12 volt cannot pass to this side. So the next issue, battery not recognized. So for the battery not recognized issue, it could be the battery, of course, it could be the motherboard of the battery or the connector. Try to clean the connector, and of course it could be the SIO. Or sometimes it could be out of hardware. You can find a virus or a malware. So you can also check the software part. So the next issue, the laptop power on just on battery but not on adapter. So in this case we have problem here in this part. So when the laptop powers using the battery but not adapter, the problem could be here, especially this switch, because this one is for protection. 19 volt can pass to this side, but this one is failed, so it will not pass here. So we will not get B+. But if the battery is good, we will get B+. So the problem could be this one, or could be also the charge IC. So please, for laptop only powers on with battery, check the switch and check the IC. So the next failure, laptop turn off when unplugged. Easy. So when laptop turn off when unplugged, go ahead and change the battery or check this connector. It could be dirty. The next issue, battery drains too quickly. So when battery drains too quickly, means of course you have problem with the battery, or you have a short circuit somewhere in the motherboard. In this case, based on my experience, if you try another battery but the problem stay the same, try to clean the whole motherboard, because it could be dirty and there is a lack of current somewhere in the motherboard. So try another battery and clean the whole motherboard, especially the charge circuit. The next issue, adapter connected, not charging. So when the adapter is connected but no charging, of course it could be the battery is a bad battery, it could be this connector. Also you should clean the connector, make sure the battery is inserted correctly to the motherboard or to the connector. So check also the DC jack or the power jack. And of course it could be the charge IC that doesn't generate the lower gate and the upper gate. Could be the store MOSFET and could be also the SIO. The next issue, battery percentage stack. So when the battery percentage stack, in this case, the problem could be here with this signal, SMD data. Means the battery state is not reported to the SIO. Means the problem could be in the SIO or in the motherboard within the battery. Next issue, laptop charging slowly. So in this case, when laptop charging slowly, it could be the current that is generated here is not enough for the battery, or it could be the battery itself, or it could be a dirty connector. So, but in this case, always try to check this MOSFET. You can even replace this MOSFET because this MOSFET has the purpose to increase the current because it is connected to the ground. Always the MOSFET that is connected to the ground has the purpose to adjust the voltage and the current. So try to check this MOSFET and also the inductor, could be the failed one, and also the current sense resistor. So for this kind of issue, check the battery, motherboard, the connector, the current sense resistor, the inductor, and this MOSFET. So the next issue, charging but not increasing the percentage. So here, of course, always we have problem with this signal because all about states of motherboard, this is the signal that is connected to the motherboard in pin number 5. Here we have pin number 5. So try to clean this connector, and also the SIO could be the cause of this failure. So the next issue, plug it in, not charging. So for this issue, plug it in means the adapter is plugged in but not charging. It could be the adapter itself, it could be the DC jack, it could be the charge IC, it could be the store MOSFET, it could be the connector, a dirty connector, or it could be the battery itself. The next issue, inconsistent charging behavior. Inconsistent charging behavior always refer to this. This is a very important signal. SMD data assess the state of the battery. So for this problem, inconsistent charging behavior, it could be the CPU IO or could be the motherboard inside the battery, means the battery. So the next issue, laptop charger light blinking, not showing. So in this case, it could be the SIO. The SIO is the first cause for this case. The next issue, laptop doesn't recognize the charger. So for the laptop doesn't recognize charger, it could be the charger itself. This kind of issue is usually happen in the Dell laptops, but it could be the DC jack, the charger, it could be the IC itself doesn't recognize the charger. Also, it could be the SIO. The last issue, power adapter overheating. So when we have the problem of power adapter is overheating, of course we have to use another power adapter to make sure if the power adapter is bad or not, but it could be also the charge IC. So thank you very much guys, I hope that you enjoyed the video. Please don't forget to subscribe and hit the bell icon, like and share the video. Thank you very much and see you in the next video.